Thank you for returning for part 3 of 3 of our reliability model discussion. In this session, we're going to incorporate the Weibull and Poisson distributions that we discussed in part 2, and we're going to propose a budget solution for how we can fund the maintenance of our equipment because of the reliability. So we'll come back here, and we're going to put in our Weibull distributions. We're going to change this to the Weibull distribution, and we're going to have an alpha and a k, I believe, right? And that alpha and k are going to be 250 and 1.5. So we'll put those in here. And then over here, we wanted to use the Poisson distribution. And now we're not going to have the min, most likely, and max. We're going to have what? Just a single parameter of lambda. And we're going to have, we'll just clear all that, and then we'll put in here a value of 21. And now we need to define our distributions again. We can just redefine them right over here. So this is going to be the SIPmath generated input, the Weibull distribution, and we're going to have a lambda here, followed by a k, followed by a seed. Okay. Okay. And some of you is going to write over it because I already had something in that cell. Now what's nice here is I can just copy that equation down here to all the others. And my mean time to repair, this is going to be the Poisson generate input, Poisson, the lambda is here, and I need a random cell, so I'll just put the random cell right here, and SIPmath will generate that for me. You'll see. Yes. So now I've generated the random number. So I guess I need to copy that down. I'll get this done yet. And we'll copy the distribution equation down. Now that we have that done, we can go down and look at the results. All the rest of the model has just used those new distributions to recalculate all the equations. Failure time looks different. It's shorter, as we expected. We still have the central limit theorem coming into play here. What happened to this repair time per cycle? You can see that they're identical. So I didn't have the central limit theorem apply. Here I've corrected the model to properly reflect the Poisson distribution. And as we can see, the single Poisson shown here in the blue, and the average of the 7 Poissons shown here. So the central limit did apply. We can scroll down here. The repair cost didn't change. And here's our MPV now at 10,558. Repair cost uncertainty by year has been updated. Looks pretty similar to before. So that change really didn't have a huge difference in our model, but maybe we feel better about the distributions now. We were asked to look at the budget. And while we could look at a budget that equal to the expected value, as we've shown before, if we look at the various trials, even now, sometimes these trials are going to be even over our P90. And so the question becomes, is that the right budget to have? Or should we have a budget that looks more like an accrual? If you think about an insurance company on houses, they have set aside an accrual for when they have a disaster, because the disaster is going to require more than the average for the year. So what I've done in this model is I have added some new parameters. I've added the cum expense by year. So here's the cum expense for 2018, 19, 20, 21, and 22. And then I've calculated the average and the P10 and the P90 for those through here. Then we've plotted them over on this side. So this represents the cum that would go into our kitty, if you will, for repairs. And here is the P90 and the P10. And here's the average for the year. So what are the benefits of SIPmath? Well, first of all, it's free. At least the free version is, compared to $1,000 to $2,000 for other simulation software. It has most of the typical statistical distributions. We can include correlation among the variables with the enterprise version of the tool, which costs $500. The free version does include resampling. We can define user graphics for comparing distributions. The model is transferable to any Excel user. Most of the other commercial software, if you don't have that software on your machine, you can't really look at the model. These models are fully transferable to other people because the SIPmath tool is designed only to build the model, not to run the model. And it does run on both PC and Mac. It's fast as it's using the database function. It's generally easy to incorporate SIPmath or convert to a SIPmath model. We can control the random number seed for each of the uncertainties. Typically in the other softwares, you only have one seed, if you even use one seed. And as a consequence, you can easily get different answers. We can scroll through the simulations as we've seen in the demonstration, and we can trace individual outcomes and see it in the Excel model. This is very helpful when debugging your model. If you want more information on SIPmath, you can visit probabilitymanagement.org. I hope you will download the SIPmath toolbar. And maybe you want to review some of my instructional videos on how to use SIPmath on YouTube. So if you want to contact me, I'm available on LinkedIn and also brian@theputz.com. Thank you for watching.